Here's an example of how to solve the missing variables of a right triangle using trigonometry. The given variables are beta in the left hand corner of the right triangle, and below it's the variable of b, and the hypotenuse is c. Given information is that alpha, its measure is 20 degrees, and its opposite side called A, is 12.3. Going alphabetically, first we're going to find the value of b, the length of b, using tangent. Therefore, setting up our equation, we have tangent of 20 degrees equals 12.3 over b. This equation of tangent can be solved using algebra, and so using algebra we can rewrite this in another way. By cross multiplying, we can state that the tangent of 20 degrees times b is equal to 12.3. Again, using our algebraic skills, we can state that if we divide both sides by 20 degrees, then we can isolate the b variable on the left side of the equation, thus giving us the answer of b on the right side of the equation. We're actually going to find the approximate answer to this by using a scientific calculator. So using a TI-84 calculator, we're going to punch it in, straightforward, 12.3 divided by tangent of 20 degrees. Now please make sure that the calculator is already in degree mode, and if so, then you should get the answer shown. So now I'm going to transfer the approximate answer onto my paper. So again, the distance of the adjacent side to alpha is approximately, up to 3 decimals, 33.794 and that's one answer. Going alphabetically, we found B. Then next up is the hypotenuse, C. So again, the first thing we're going to do is we're going to set up our trigonometric ratio. We're going to use the formula of sine, since we have the opposite of alpha, that's 12.3, and because we want to find the hypotenuse. So which trigonometric function offers opposite and hypotenuse? That's sine. So again, we set up our formula. We're going to use algebra to solve. Let's watch. So again, up to 3 decimals, the approximate answer is 35.963. And again, we just found the distance of the hypotenuse of the right triangle. So 2 variables down and 1 to go. Now we are to find beta. Again, beta is a Greek letter used for variables, usually in trigonometry, to represent angles. So we have used tangent, we have used sine. To find beta, we're going to use cosine. From beta's perspective, b is the opposite. But to show that we can use cosine. We can relate to the given information, which was the length of A, which was given 12.3. From the perspective of beta, 12.3 is the adjacent side towards it. And again, the trigonometric rational definition of cosine is the adjacent side over the hypotenuse. So we're going to write 12.3 over C. The value of C, which we already know from the prior answer, will be applied and substituted here for us to find the value of beta. Let's watch. So as you can see, 12.3 will be divided by the prior answer. Now we're only showing 3 decimals, but we're actually going to divide 12.3 by all of the answer that we still have in our calculator, and then we're going to use the inverse of cosine to show that the exact answer or the exact value of the beta degree is actually 70 degrees. And we can use simple geometry to find that. But using trigonometry, again, we can just take the last answer to divide 12.3. So using a calculator, you should be able to use your answer button to take one answer onto the next step. That way you do not round off any decimals, and you show or give the best accurate answer all the way. And so if you use your answer button and you do not erase and round off any decimals, you should get exactly 70 degrees. There's your answer. But overall we found 3 answers. We found beta, an angle, and then we found 2 distances.